Hello, my dear students. It's my pleasure to meet you again. Today, inshallah, we are going to study a new lesson, which is similarity of two triangles. The last period, we studied the similarity case 1. Now, inshallah, we are going to study case 2 and case 3. Okay? Let's concentrate here. If we draw a right angle triangle like that, we have here a right angle triangle, and we will draw perpendicular from right angle. We have here a right angle triangle A, B, C, and we draw perpendicular from A to BC, which is intersect CB and D, and we have here right angle. Of course, we have here a right angle also. So from previous studying in second primary preparatory, we remember about Euclidean theorem. What is the Euclidean theorem? We have AB power 2 equals BD multiplied by BC. And also we have AC power 2 equals CD multiplied by CB. And we have also AD power 2 equals DB multiplied by DC. And we have AB multiplied by AC equals AD multiplied by CB. We have studied these 4 rules from Euclidean theorem, but we don't know why. Why in right angle triangle here, if we draw perpendicular here, these rules will be exist. From similarity now we can prove that. Okay? Let's move to how to prove that Euclidean theorem from similarity. Okay? We will draw the same triangle here, right angle triangle ABC. ABC is a right angle triangle at A, and we draw AD perpendicular to CB, and we want to prove these 4 rules from it by using similarity. Okay. If we consider that this angle is 40 degrees here, measure angle BAD is 40, and we have measure angle BAC, of course it's 90, so measure angle DAC will be 50. Okay, what about measure angle B? We know that here is 90, and we know that the measure angles of the interior angles of triangle equals 180, so 180 minus 4 plus 90 will be 50 also. And also we know that measure angle ADC is 90, so we can easily deduce that measure angle ACD is 40. So it's clear to us now that if we have a right angle triangle like that and perpendicular AD to CB like that, so the measure angle BAD of course equals the measure angle C, and also measure angle DAC equals measure angle B. And we know that measure angle ADB equal measure angle ADC, right angle. So we know about similarity of angle. Two angles here in triangle equal two angles here triangle. So triangle ADB of course will be similar to triangle C. We said ABD. A is 40 or dot here, so it's corresponding to C, which is 40 also, or dot. Okay, and D here is right angle, so we'll go to D also is right angle in the other triangle here, and so it's CDA. Okay, and of course from the last period we have studied that if we have these two triangles are similar, then we will deduce that the corresponding sides are proportional. So AD over CD will be equal to DB over DA equals AB over CA. Okay, and what we will deduce from that? We have here AD over CD, okay, AD over CD equals BD over DA equals AB over AC. Also, each triangle of these two triangles of course will similar to the big triangle or the whole triangle ABC. Why? If we concentrate on the triangle ADB, we will have the angle B is common triangle between triangle ABD and triangle ABC, of course. And we know that this angle in the triangle ADB equals the angle A, which is 90 also. So we can say that triangle ABD is similar to triangle. We say about D is right angle here. It's corresponding to A, which is corresponding to the right angle. So the angle A here is 40 in triangle DAB. Measure angle DAB is 40 and measure angle ADB is 90. So D will corresponding to A in the big triangle. And we know that B is common angle. We can put B corresponding to B. So the triangle here will be ABC. And also we can say that AB over CB will be equal BD over BA, of course equals AD over CA. We have talked about triangle ABD and triangle ABC, okay, here. And we have talked about the two triangles, the small triangles ABD and ACD here. Let's talk about the triangle ADC and triangle ABC. Triangle ABC here, ADC, is similar to triangle. We know that the measure angle ADC, which is D, is corresponding to the measure angle A, which is 90. And we know C is common angle between the small triangle and the big triangle. So it's C now. So the triangle CAB. So we can deduce easily that AD over AB AD over AB or BA, it makes no difference, equals DC over AC equals AC over BC. So from these triangles we can deduce easily that AB power 2, we can use another paper to complete. We will use that AB power 2 equals BD times BC, and also we will deduce that AC power 2 equals CD times CB, and also we can deduce that AD power 2 equals DB times DC. And finally, we can use that AB times AC equals AD times BC. And we can use directly these rules to find unknown sides, or as the example, the following example, it's Bx or Y. Let's move to the next example to understand that well. We have an example. We will use these 4 rules or some of them in this example or solving it. So we have a right angle triangle, the same right angle triangle here, like that. And from right angle we drew perpendicular to BC. This is right angle and AD perpendicular to BC, and we have here CD is 8 centimeter length and DB equals 4.5 centimeter length, and BD is Y minus 3 centimeter length, and BC AC is 3x plus 4 centimeter length, and the requisite is to find the value of x and y. Solution here is very easy because from similarity of the 3 triangles, the triangle ADB and triangle ADC and triangle ABC, which we studied before, we will use the rules to find y here. We will use the rule AD power 2 equals DB multiplied by DC. AD power 2 here is y minus 3 power 2, and DB is 4.5, and DC will be 8. Okay. To find y minus 3 only and cancel power 2, we will take square root 4.5 multiplied by 8. It will be y minus 3. And someone say, Mister, we have to put here positive or negative. Yes, of course. But here we are dealing with numbers. So we cannot put negative. So we will have positive only. So y minus 3 equals square root 4.5 multiplied by 8. We will use calculator here to find the answer. It's easy. Square root 4.5 multiplied by 8. Then the answer will be 6. And we will solve this. We transfer negative 3 will be positive 3. Y equals 6 plus 3. Then y, of course, equals 9 centimeter. Okay, so y is equal 9. To find x, we will deal with AC here. And we know from the similarity that we can say that AC power 2 equals CD multiplied by CB. AC power 2 will mean that 3x plus 4 all power 2. And it will be also equals 8, which is CD, multiplied by CB. Yes, 8 plus 4.5 equal 12.5 centimeters. And we will cancel power 2 by taking square root as of the previous example. 3x plus 4 here equals square root 8 multiplied by 12.5. And 3x plus 4 will be equals 10. And we will continue solving this equation. 3x here equals 10 minus 4 equals 6. And also x equals 6 divided by 3 equals 2. So x here equals 2. And we have solved the first example, which is for us is very easy. Okay, let's move to another example on the same rule. Okay, here we have also right angle triangle. We will draw a right angle triangle and we will complete it. But we will use the rule inside the rectangle now. We have another example. If we have a rectangle like that, we will draw a rectangle which is each other. We have a rectangle here, A, B, C, and D. We know about rectangle, all angles are right, and each of them equal 90, of course. And let us join AC, the diagonal AC. Okay, and let us draw perpendicular from D, a perpendicular ray like that, from D to the point E, and let us call this point as F. Okay, we have here a rectangle ABCD, and we know that each angle is 90 or right angle, And if we draw AF passing through E and perpendicular to AC, intersecting it at E and intersecting CB at F, what's the request here? The request is to prove that area of rectangle ABCD, area of rectangle ABCD equals square root AE multiplied by AC multiplied by DE multiplied by DF. Okay? The request to prove that the area of rectangle equal this square root. And we will try to prove that. Okay? First, let's move to the triangle ADC. Look carefully to triangle ADC now. We notice that here D is right angle, and from right angle we draw perpendicular DE to AC. So we can say that AD power 2 here is AE multiplied by AC. So someone think why we think like that, why we say AD. We know that the area of rectangle equal length multiplied by width. So where is length? Length here is DA, which is equal CB, and width of course equal DC, which is equal AB. So we will try to find length and to find width and multiply each other in terms of these sides. So in triangle ADC, we notice that D is right angle and DE is perpendicular. So we can easily say that DA power 2 equals AE multiplied by AC from Euclidean theorem or from similarity, which we have already do it. Okay, and also we will move to the triangle DCF. Why this triangle specifically? We have here right angle, and CE is perpendicular also to DF, and we can say that the triangle that DC power 2 equals what? Equal DE multiplied by DF. So we can say DC power 2 equals DE multiplied by DF. Say this is 1 and say this is 2, and from 1 and 2 here DA power 2 means L power 2, and DC power 2 means width power 2, and we would like to find L also. L here equals square root AE multiplied by AC, and W, which is the width, equal DE multiplied by DF. And we have studied that length multiplied by width equals the area of triangle, and also we said that about L equal positive or negative. We ignore negative because this square root will deal with numbers. Okay, our length here cannot be negative. So by multiplying area of rectangle ABC equal length multiply width, which is square root AE multiplied by AC times the other square root, which is DE times DF, and we can say that the area of triangle equals AE multiplied by AC multiplied by DE multiplied by DF. We notice that we join all these numbers in one square root. From the properties of square roots, if we multiply them, we can join them in one square root. But plus or minus it cannot be. Okay? So we can here prove that the area of rectangle ABCD equals square root AE multiply AC multiply DA multiply DF, which is the proof of the area of rectangle. Let's move, my dear students, to another case of similarity of two triangles. We have studied before about the case of AA triangle, AA similarity, which means that angle, it's enough to prove that two angles in first triangle equals two angles in second triangle, then it will be, the two triangles will be similar. But let us talk about the second case, which is SSS triangle. But after we will take some break and return again. We will talk about it. Okay, my dear students, we returned again. Let's talk about the second case, which is SSS similarity. What is SSS similarity? SSS similarity means side, side, side. So if the two corresponding triangles has two corresponding sides, each two corresponding sides are proportional, then it will be similar. So let's concentrate about these two triangles. If we have a triangle like that, that is ABC triangle, and this small one says that AB here is 10 centimeter, BC is 8 centimeter, and EC is 9 centimeter. And this triangle XYZ here, if XY is 5 centimeter, ZY is 4 centimeters, and XZ is 4.5 centimeters. So look carefully here. If AB over XY here, AB over XY, it will be 10 over 5, and it will be 2. Call this equation is 1. And also AC over XZ equal 9 over 4.5. It equal 2 also. This is equation number 2. And also, and finally, BC over YZ equals 8 over 4 equals 2 also. From this equation and this one, we will deduce that AB over XY, which is equal to, equals AC over XZ, which equal to, equal BC over YZ. So from 1, 2, and 3, we will deduce that AB over XY equals AC over XZ equals BC over YZ. Okay, so each two corresponding sides here are proportional. This side over this side makes a ratio equals this side over this side equals the other ratio, and BC over YZ is the third ratio, and these three ratios are equal, so the corresponding sides here are proportional. So we can say that the two triangles here are similar because of SSS similarity, which is the second case of similarity. Okay? SSS similarity, which deals with the three sides here corresponding to the three sides here in the second triangle. And we know that 2 here called the ratio of similarity or similarity ratio. Okay? And because it's greater than 1, then this triangle will be enlargement of this triangle. Triangle ABC here is enlargement to triangle XYZ. And if we find the reciprocal of this ratio, XY over AB, it will be half. And of course, XZ here over AC will be half. And finally, YZ over BC equals half. So the three ratios here also will be equal. And we can say that the triangle XYZ here is minimized or shrinking to the triangle ABC because the ratio of similarity here is smaller than 1 or between 0 and 1. Okay, let's move to another example, my dear students, to understand well how we can deal with solving exercises on this case. If we have a triangle like that, try to concentrate with me. We will draw a triangle. This is BAC triangle, and we have another triangle up to the first one. We called it BED. Okay, so we have two triangles here, and we have some lengths. We have BA equals 8 centimeter, AC equals 12 centimeter, CD equals 4 centimeter, DB equals 12 centimeter, EB equals 6 centimeter, and finally ED equals 9 centimeter. The request is to prove that the two triangles here are similar. The two triangles, first request is the two triangles are similar. And unfortunately, he didn't tell me the arrangement of these triangles. And inshallah, we're going to prove it easily. And second request is to prove that the ray BD here bisects the angle ABE. Where is BD? The ray BD here is this one. The request is to prove that it bisects the angle EBA. That means that we would like to prove that the measure angle EBD equals measure angle ABC. Okay, let's move to solve this solution. So example. First, we have a challenge in determining what the arrangement of these triangles. But we have easy way to do that. If we arrange this triangle here from the smallest side to the greatest side, so we can talk it about EAD. Why EBED, not BDA? Here BE is the smallest side, and ED is the middle side in the length, and the last one is the biggest side, which is DB. So we can say triangle BED, because BE 6 centimeters is the smallest, ED is bigger than the smallest one, and DB is the biggest. So we can write the name of triangle well by from the smallest to the biggest of the length of the sides. And the other triangle we have here, BA equal 8, AC equal 12, and of course the last side, which is BC, equal 12 plus 4, which is 16. So we can say that we can name it by BAC, because BA is the smallest one, AC is bigger and is the biggest, and the BC is the biggest. So we can say about triangle BAC. And we will try to prove that this triangle is similar to this triangle. To prove that, we will divide BE over BA. BE here equals 6 centimeters and BA equals 8 centimeters. In simplest form, by dividing them by 2, it will be 3 over 4. And say it as number 1. Let's move to another ratio, DE over AC. DE here is 9 and AC is 12. By simplest form, by simplify them, by dividing them by 3, it will be 3 over 4. Took it, we will call it the number 2 equation. And the last ratio is BD over BC. BD equals 12 and BC, all of them, 12 plus 4 equals 16. And by simplifying it, by dividing them by 4, it will be 3 over 4. What we notice here, we notice that the first ratio here equals 3 over 4, the second ratio equals 3 over 4, and the last ratio equals the same number, which is 3 over 4. So we can say that BE over BA equals DE over AC equals BD over BC. And now we have said that we have each ratio equal the other, so each two corresponding sides are proportional. So by the case SS similarity, we have proved that the triangle BED is similar to the other triangle, which is BAC. Okay, my dear students, let's us to move to another case, which is SAS similarity. We have studied two cases up till now. The first case is AA similarity, which is angle-angle similarity, which means that two angles in the first triangle equal two angles in the second triangle, so the two triangles will be similar. And the second case, SSS similarity, which means that each two corresponding sides are proportional, so the two triangles are similar. Let's move to the third case, which is SAS similarity. What is the meaning of SAS similarity? SAS similarity means that side and other side, and including a specific angle. Let's do it in drawing to be clear to you. if we have a triangle here, ABC, ABC triangle, and another smaller one, which is XYZ triangle, XYZ, and the measure angle of A equals the measure angle of X. This is the first of all, first condition. And we have AB, say 6 centimeters, and say that the length of XY equals 3 centimeters, and AC here is 7 centimeter, and the length of XZ equals 3.5 centimeter. So we have measure angle A equal measure angle X. If we divide XZ over AC here, XZ over AC, it will be 3.5 over 7, which is half. This is the first ratio. And XY, if we divide it by AB, then XY equals 3 over AB, which is 6, equals half. So we have two sides are proportional. XY and AB are corresponding sides, and they are proportional because it is equal to the ratio which is XZ over AC. And concentrate carefully that each two sides here includes the angle X, and each of the two sides here includes the angle A, which are equal to each other in measure. So it will be SAS similarity. Two sides are proportional, and the included angle between them here equal in measure. So the two triangles, if satisfy these two case, two triangles will be similar. Okay, let's move to solve another example on this case. It will be easy example for you. Let's draw a triangle like that. Concentrate with me here. This is a triangle. We can call this triangle ABC. Okay. And let's bisect AB by the bisector point D, and DB equals 3 centimeter, and D equals 3 centimeter also. So DB equal DA. Okay. And draw DH such that HB here equal 2 centimeters, and BC, all of BC here equals 9 centimeter. The total side here is 9. And the request is to prove that the triangle, first one, to prove that triangle DBH is similar to triangle CBA. This is the first request. The second one is to prove that ADHC is a cyclic quad. Let's solve it. Here we have two triangles, DBH, this is a triangle, and that triangle is CBA. Look carefully about these two triangles. This one, the small one, and the whole triangle, which is CBA. What do you notice? What about angles? Is there any equal angles here? Yes, intelligent students notice that the angle here A is a common angle, so it is equal in two triangles. So measure angle B here is a common angle because it is in triangle HBD and in triangle CBA also. So it is common angle, so it's equal in the two triangles. And look carefully to BD and BA. BA here equals 6 centimeter, the whole side, and BH is equal 2 centimeter, and the whole side BC equal 9 centimeter. Someone says that, what about this? Is it included angle? Yes, of course. And if we divide 3 over 6, BD over BA, BD over BA 3 over 6 equal half. What about the other side? BH over BC is 2 over 9, and it is impossible to equal because here BD over BA equals half, but BH over BC equal 2 over 9, and they are not equal. So what we will do, if some of you notice that D here is corresponding to C, so when we start by D, we will start this other side with C, and we will take CDB with CB. Okay, so if we divide BD but over BC, BD here over BC, it will be 3 over 9. In simplest form will be 1 over 3. This is the first ratio, and the second ratio will be BH because H here is corresponding to A. So we will start BH over BA. BH here equal 2 and BA equal 6, and we will simplify it, will be 1 over 3. This is equation number 2, and we deduce that from these two ratios that BD over BC, of course, equals BH over BA, which is equal 1 over 3. So the angle A, the angle B here is the common angle, so its angle. The side BD over BC, which is the first S, equal the side BH over BA, which is the second S, and angle B is included between them. So this case is satisfied. So the triangle DBH is similar to triangle CBA. So now we proved that the triangle, this triangle, which is a small one, is similar to the bigger triangle. Don't forget about the second request. What about the second request, and what is a cyclic quad? Look carefully for the quad ADHC. ADHC. Try to remember what you studied in third preparatory. In third preparatory second term, we studied about the cyclic quad, and one of the conditions is if we have an exterior angle of the quad here on a vertex equal the opposite angle of this vertex, then this quad is cyclic. What is the meaning of cyclic? It can be a circle passes through it, A, D, H, and C. So is the angle BHD equal the angle A? Look here. The angle BHD BHD. Look carefully at this. Okay, look carefully at this arrangement. The angle BHD, of course, it will be equal to the angle BAC. So the measure angle BHD equal measure angle BAC. So an exterior angle equal the corresponding interior angle to opposite to this vertex. Then the quad DACH is a cyclic quad. Okay, my dear students, I am pleasure to meet you today. Until we meet again next time or next period, inshallah, we will try to keep yourself home and try to be safe. Study well. Goodbye and good luck.